In this lesson, we are going to discuss single replacement or substitution reactions. At the end of this video lesson, you should be able to define single replacement or substitution reactions and predict the reactants or products of single replacement reactions. Single replacement reactions are also known as substitution reactions. In these reactions, either the cation or an ion of an ionic compound is replaced by a more reactive and uncombined element. To better understand the definition of single replacement reactions, let us look at the general formulas for single replacement reactions. In single replacement reactions, an ionic compound, may it be binary or polyatomic, reacts with a free element. For this first general formula, the free element is a metal and will form a positive ion. The rule on single replacement reactions is that cation-forming elements will replace cations, and anion-forming elements will replace anions. Since the free element here is a cation-forming element, it will replace the cation in the ionic compound, which is A. This will produce compound Cb and the free element A. Compound Cb is written as such because in ionic compounds, the cation is written first. On the other hand, substance A does not have any charge because it exists as a free element. Single replacement reactions also happen on anions. In the second general formula, the free element is an anion-forming element. It will replace B in the ionic compound. Thus, the products will be compound AC and the free element B. Again, the free element in the product side will not have a charge because it does not exist as an ion. Single replacement reactions will not proceed as it is. The free element should always be more reactive than the element that is replacing in the compound for the reaction to proceed. This will always be determined by the activity series. The activity series determines the reactivity of the elements. We have here two activity series, one for cations and one for anions. Reactivity increases from the lowermost element to the uppermost element. To determine whether a single replacement reaction will proceed or not, we are going to look at the free element in the series. For example, in a reaction, the free element is zinc. A reaction will only proceed if the element that it is replacing in the compound is lower in the activity series for cations. So for zinc, it may replace iron, cadmium, nickel, tin, lead, hydrogen, copper, mercury, silver, or gold. However, it will never be able to replace the elements higher than it in the series. These are lithium, potassium, barium, carbon, sodium, magnesium, and aluminum. This is because of the higher reactivity of the said elements. The same rules apply for the anion activity series. For example, the free element is bromine. It will only replace those that are less reactive. These are iodine, sulfur, and phosphorus. It cannot replace those that are more reactive. These are fluorine, chlorine, and oxygen. Let us look at the following examples for single replacement reactions. For the first example, we have hydrochloric acid reacting with magnesium. The first step in identifying the products of a single replacement reaction is to identify the charges of the substances if they will form ions. Magnesium is a metal. Therefore, it is a cation-forming element. For hydrochloric acid, hydrogen is the positive ion and chloride is the negative ion. The rule is positive replaces positive and negative replaces negative. Since magnesium is positive, it will replace hydrogen from the acid compound, but only if it is higher in the activity series. We are going to use the metals activity series since metals are involved. Magnesium is higher than hydrogen in the series. Therefore, this reaction will proceed. To write the product, we need to identify the charges of the ions. Magnesium, being in group 2, has a charge of positive 2. Chloride ion has negative 1 charge. Therefore, magnesium chloride is MgCl2. The other product is the element that was replaced, and that is hydrogen. But this is written as H sub 2 because hydrogen is a diatomic element. For the complete balance reaction, we have 2 moles of hydrochloric acid reacting with 1 mole of magnesium to produce 1 mole of magnesium chloride and 1 mole of hydrogen. For the next example, we're going to predict the products of the reaction between potassium iodide and bromine. Bromine is an anion-forming element. In potassium iodide, potassium is the positive ion, and iodide is the negative ion. Thus, bromine will replace iodine but only if it is higher in the non-metal activity series. Since bromine is higher than iodine, the reaction will proceed. Both potassium and bromine have a charge of 1. Thus, potassium bromide is written as KBr. The new free element will be iodine, which is written as a diatomic iodine. Therefore, the complete balance reaction is 2 moles of potassium iodide reacts with 1 mole of bromine to form 2 moles of potassium bromide and 1 mole of iodine. For the next example, we have sodium reacting with water. Sodium is a metal. Therefore, it is a cation-forming element. It will replace the positive ion in water. Water will form 2 ions, particularly the positive hydrogen ion and the negative hydroxide ion. Using the reactivity series, we can see that sodium is higher than hydrogen. Therefore, the reaction will proceed. As sodium replaces hydrogen, a base will be formed. This is sodium hydroxide. The other product will be the free element, and this is hydrogen as a diatomic element. The complete balance reaction is 2 moles of sodium reacts with 2 moles of water to produce 2 moles of sodium hydroxide and 1 mole of the diatomic hydrogen. For the next reaction, we have lead-4 nitrite reacts with silver. Silver is a metal, thus a cation-forming element. In lead-4 nitrite, lead-4 is the positive ion, and nitrite is the negative ion. Therefore, silver will replace lead-4 in the compound. However, looking at the activity series, silver is way lower than lead. Therefore, the reaction will not proceed. For the last example, we have the reaction between iron 2 nitrate and zinc. Zinc is a metal, a cation-forming element. In the compound, iron 2 is the cation and nitrate is the anion. Therefore, zinc will replace iron 2. In the activity series, zinc is 1 level higher than iron. Therefore, the reaction will proceed. Zinc, having a charge of positive 2, will bond with nitrate which has a charge of negative 1. Thus, we have zinc nitrate. The free element is the replaced metal and this is iron. Iron is written as a pure element here since it is not in the cationic form. Since the reaction is already balanced, the complete reaction is 1 mole of iron 2 nitrate reacts with 1 mole of zinc to produce 1 mole of zinc nitrate and 1 mole of free iron. To conclude this lesson, let us review the following key points. Single replacement or substitution reactions involve ions replacing a less reactive element from a compound. The reactivity of metals and nonmetals can be determined by using the reactivity series. And lastly, substitution will only occur if the free element is more reactive or higher in the reactivity series than the element that it is replacing in the compound. And that ends our discussion on single replacement or substitution reactions.